So in this video, we're going to talk about how to solve problems with exponential and logarithmic functions. So remember, we talked about exponential equations, which have the form y equals a times b to the x. We also talked about exponential growth and decay when we have an r value, the rate of change that is given by a percentage. We also talked about compound interest problems, which is an adjustment that we made for interest that was compounded at a certain schedule per year. And we also talked about half-life problems, which help us determine what's going on with radioactive decay. So we're going to use these different formulas to figure out how to solve different types of real-life situations. So it says the population of a town is 5,000 in the year 2010. And then it increases by 12% each year. Write an equation to model the population y of the town x years after 2010. So let's go ahead and figure out which formula to use. So since we have a percentage, we're going to use this y equals a times 1 plus or minus r to the t. Since it is increasing, we're going to say that y equals a times 1 plus r to the t, right? Because it's going to be exponential growth. So let's substitute the variables we have. So we have a, the initial value, which is 5,000. We have r, which is the growth rate, so that's 12%. Remember, it needs to be converted to a decimal, so that is 0.12. And then we have t, which is the amount of time, so that's going to be x years. So let's go ahead and substitute into this formula what we have. So we have y equals 5,000 times 1 plus 0.12 to the t, which is x. So if we plug that all in, we have 5,000 times 1.12 to the x. And so that equation will tell us the population of a town x years after 2010. We don't need to solve anything because notice in this problem it's asking us just to write an equation. So in this problem it says a radioactive substance has an initial mass of 200 grams and a half-life of 5 days. Write an equation to determine the number of days x required for the substance to decay to 27 grams. So whenever we're talking about radioactive decay, we're going to use this half-life formula, right? So we have this a equals a naught times 1/2 to the t over h. Okay, so let's substitute in what we have. So we have a naught, the initial mass of 200 grams. We have t, which is the amount of time, but that tells us it's x days. We have h, which is the half-life, so that's 5 days. And then we have the final amount of substance that's left, that's a, which is 27 grams. Okay, so if we plug into this equation, we have 27 equals 200 times 1/2 to the t, which is x, over h, which is 5. Okay, so once again, it just wants us to write the equation, so we're just going to leave our answer like that. So in this problem, it says the population of bacteria in a petri dish doubles every 8 hours. The population is initially 200 organisms. How long will it take for the population to reach 1,000? So whenever we have something like that going on and growth rate is not a percentage, we're going to use that y equals ab to the x. And then we're going to figure out what we need to plug into this problem. So we have a, the initial value, which is 200 organisms. We have b, the growth rate, so it's doubling, so that growth rate is going to be 2. We'll talk about how this 8 hours factors in a little bit later in the problem. And then we have x, which is the amount of time, so we don't know that, so that's what we're trying to solve for. And it tells us that the population reaches 1,000, so that tells us that y equals 1,000. So if we plug into this formula, we have 1,000 equals 200 times 2 to the x. So now we're going to work on solving this. So to solve, we need to get that term that has a variable by itself. So we're going to divide both sides by 200. So when we do that, 1,000 over 200 is 5. So we have 5 equals 2 to the x. Now to solve, we need to go ahead and take the log of both sides. So we have the log of 5 equals the log of 2 to the x. So now what we can do is we can use that power property to bring that x down in front, right? So this is going to be the log of 5 equals x log 2. And so we can divide both sides by the log of 2 in order to solve for x. Okay, so the log of 5 divided by the log of 2 equals x. So if we do that on our calculator, we're going to go ahead and type that in. So we have log of 5, enter, and then divided by log of 2. And that tells you that x is approximately equal to 2.2 2.3219. Okay, so what we can do now is we can figure out how much time it's been. Okay, here's where the 8 hours factors in. So the 2.3219 doesn't tell me exactly how many hours it's been. It tells me how many times 8 hours has passed. Okay, so to figure out the amount of time, we're going to take that 2.3219 and we're going to multiply it by 8. So when we do that, we get 18.5, right? So that's 18.5, so we would say that is about 19 hours, okay? So you have to do that extra step because it's a doubling every 8 hours. So in this problem, it says that Susan invests $6,000 in an account that earns 1.4 annual interest compounded quarterly. How many years will it take for the balance of the account to reach $12,000? Round your answer to the nearest tenth. So for compound interest, we're going to use this formula. And so let's go ahead and see what we are given in this problem that we can plug into this formula. So we have A, which is the initial amount, so that's $6,000. We have R, which is the rate, right? So that tells us 1.4%, which we can convert to a decimal. That is going to be 0.014. And then N is the number of times it's compounded. So compounded quarterly means 4 times. And then the final value in the account that we're talking about is $12,000. So Y is going to equal 12,000. So we have 12,000 equals 6,000 times 1 plus R, which is 0.014. And then that's over N, which is 4, to the 4 times T. So we have 12,000 equals 6,000 times 1 plus 0.014 over 4. You can just do that on your calculator. That's 0.0035. And that is to the 4 times T. So we have 12,000 equals 6,000 times 1.0035 to the 4t. So I need to get that term with a variable by itself, so I'm going to divide both sides by 6,000. And so when I do that, I end up with 2 equals 1.0035 to the 4t. So now to solve this, I'm going to take the log of both sides. So I have the log of 2 equals the log of 1.0035 to the 4t. And so I'm going to use the power rule to bring that 4 down in front. So I have the log of 2 equals 4t, the log of 1.0035. So now to solve for t, I'm going to go ahead and divide both sides by the log of 1.0035. And so that gives me the log of 2 over the log of 1.0035. And that equals, on the right side, I have 4t. Now I need to divide both sides by 4 in order to get that t by itself. So I have the log of 2 over 4 log 1.0035. Okay, and that equals t. What I can do now is I can go to my calculator and type that in to get an approximate number. So I'm going to do log of 2, enter, and then divide it by 4 log 1.0035. And when I solve that, my calculator tells me that t is approximately equal to 49.6 years. Okay, I rounded to the nearest tenth because that is what it told me to do in the original problem. So in this problem, it says that a sample originally contains 40 grams of a radioactive isotope. After 21 days, 16.2 grams of the isotope remain in the sample. What is the half-life? And round your answer to the nearest day. So for half-life, we're always going to be using this formula right here. So we have A equals A naught times 1/2 to the T over H. So let's plug in what we have. We have A naught, which is the initial amount, so that's 40 grams. We have T, which is the amount of time, so that's going to be 21 days. H is the half-life. We don't know the half-life. That's what we're trying to find. And then we have the amount that's left. That tells me that we have 16.2 grams left. So if we plug this all in, we have 16.2 equals 40 times 1/2. I'm just going to go ahead and change that 1/2 to a 0.5. So we have 0.5 to the 21 over h power. So I'm just going to divide both sides by 40 to get that term with a variable by itself. So we have 16.2 divided by 40, which is 0.405. And that equals 0.5 to the 21 over h. Now to get that variable out of the exponent, I'm going to take the log of both sides. So we have the log of 0.405 equals the log of 0.5 to the 21 over h. So I can use the power property to bring this down in front. So I have the log of 0.405 equals, and then I have 21 over h log of 0.5. And what I can do now is I can work on solving for h. So to do that, I'm just going to multiply both sides by h to get that h out of the denominator. And then, so that gives me h log 0.405 equals 21 log of 0.5. And then now I can divide both sides by the log of 0.405. And so when I do that, I have h equals 21 log 0.5 over log of 0.405. So I can now use my calculator to approximate this. So I do 21 log 0.5 and then hit enter and then do divide by log of 0.405. So that should give you about 16.1, but it says to round to the nearest day. So we're just going to round that to 16 days. And so that is our answer. So remember that logarithms and exponential equations can be used to model many real-life situations.